When black holes collide, it's one of space's most powerful events. These cosmic giants create waves in the fabric of space itself, releasing more energy in seconds than most galaxies do in years. Let's explore this incredible phenomenon. When two black holes get close enough, they start an amazing cosmic dance that scientists call orbital decay. Think of two figure skaters spinning around each other, getting closer and closer. As these massive objects circle each other, they pull on space-time like honey being stirred in a cup. They might spend millions of years moving closer, picking up speed as they go. Their massive gravity affects everything around them, pulling in nearby stars and gas, creating a bright display of light and energy. The space around them becomes warped and twisted, like a rubber sheet being stretched to its limits. As they get closer, they move faster and faster, eventually reaching speeds close to the speed of light itself. Let's talk about how black holes can literally tear stars apart. When a star gets too close to a black hole, something amazing happens. The black hole's gravity becomes so strong that it pulls harder on the front of the star than the back. This difference in gravitational pull stretches the star like taffy. Scientists call this spaghettification. Imagine pulling a marshmallow apart. That's similar to what happens to these unfortunate stars. The star gets stretched longer and longer while getting squeezed thinner and thinner from the sides. This violent process creates a spectacular light show as the star's material heats up to millions of degrees. Some of the star's remains get flung into space, while the rest feeds the hungry black hole, adding to its size. Now comes the most dramatic part of our cosmic story: the final merge. As the two black holes make their last orbits, they're moving at nearly the speed of light. The space between them becomes so twisted that they create a violent storm in space-time itself. When they finally crash together, they release an explosion of gravitational waves that ripple across the universe. This merger happens in less than a second, but it's so powerful that it shakes space itself. The energy released is greater than all the stars in the universe combined. Though we can't see it with our eyes, the two black holes become one larger black hole, spinning rapidly and settling into its new form. Scientists can detect these mergers using special instruments called LIGO, which measure tiny ripples in space from these cosmic crashes. The way we detect black hole collisions is pretty amazing. Scientists use special devices called LIGO. Think of them as giant rulers that can measure tiny stretches in space itself. These machines are so sensitive they can detect a change smaller than the width of an atom. When black holes crash together, they send waves through space that make these devices wiggle ever so slightly. It's like detecting ripples in a pond, but the pond is the fabric of space, and the ripples are traveling at the speed of light. LIGO has two facilities miles apart. When both detect the same wave pattern, scientists know they've caught a black hole collision. These discoveries have opened up a whole new way of looking at space, letting us hear the universe instead of just seeing it. Let's explore how the universe creates its biggest monsters, supermassive black holes. These giants, sitting at the centers of galaxies like our Milky Way, can be millions or even billions of times heavier than our Sun. They likely got their start when the universe was young, beginning as smaller black holes that grew by eating everything around them. Like hungry giants, they pulled in gas, dust, stars, and even other black holes. Every time they consumed something, they got a little bigger. The more they grew, the stronger their gravity became, letting them pull in even more material. Some scientists think the first ones formed when massive early stars collapsed, while others believe they came from direct collapse of huge gas clouds in the early universe. Think of it like a snowball rolling down a hill, getting bigger and bigger as it collects more snow. When black holes merge, they create an incredible light show that astronomers can spot across the universe. As these giants spiral together, they heat up nearby gas and dust to millions of degrees, making it glow super bright. This creates what we call an accretion disk, a ring of hot, glowing material that circles the black holes like a cosmic whirlpool. The disk gets brighter and more chaotic as the black holes get closer, shooting out powerful jets of energy and light. These jets can stretch for thousands of light years, glowing in different colors from radio waves to X-rays. It's like nature's biggest fireworks display, lasting for thousands or even millions of years. When the black holes finally merge, there's often a final bright flash that can outshine entire galaxies. Now let's talk about something really mind-bending: how time itself gets weird near merging black holes. As these cosmic giants get super close, time starts moving differently depending on where you are. If you could somehow watch from far away, you'd see everything near the black holes moving in slow motion. This happens because the strong gravity actually slows down time, what we call time dilation. A clock near the black holes would tick much slower than one on Earth. If you had two identical watches and put one near the merger and kept one far away, the one near the black holes would fall behind by hours, days, or even years. The closer to the black holes you get, the more extreme this effect becomes. This isn't science fiction. It's a real effect that Einstein's theories predicted, and we've actually measured on Earth, just on a much smaller scale. After black holes merge, they reshape entire galaxies in amazing ways. The newly formed bigger black hole creates powerful waves that push gas and dust around, like a stone dropped in a cosmic pond. This can trigger the birth of new stars or stop stars from forming altogether. The merger also sends shockwaves through space that can travel for thousands of light years, heating up huge regions of the galaxy. Sometimes these waves can push gas out of the galaxy completely, changing how future stars will form. The bigger black hole might start pulling in material from its surroundings, creating bright flares that can be seen across the universe. This process helps explain why galaxies look the way they do today and how they've changed over billions of years. Let's look at some of the most amazing black hole collisions we've ever spotted. Back in 2015, scientists made history when they detected GW15914, two black holes, each about 30 times heavier than our Sun, smashing together 1.3 billion light-years away. This discovery proved Einstein right and won 3 scientists the Nobel Prize. Then there's GW170817, where we saw not just the waves from the crash but also its light, a first-ever double detection. In 2019, we caught another massive collision that created a black hole 142 times heavier than our Sun, the biggest merger we've ever seen. Each of these discoveries helps us understand how black holes work and how common they are in space. Looking ahead millions of years, our galaxy's black holes are headed for some dramatic changes. The supermassive black hole at the center of our Milky Way will keep growing, pulling in more stars and gas clouds. In about 4.5 billion years, our galaxy will collide with Andromeda, and their central black holes will start their own cosmic dance. This merger will create an even bigger black hole and reshape both galaxies into one giant elliptical galaxy. Smaller black holes throughout both galaxies will gradually sink toward the center, creating a series of mergers that will echo across space. Some black holes might get kicked out of the galaxy completely by these collisions, becoming cosmic wanderers in intergalactic space. Thanks for joining me on this journey through one of space's most powerful events. If you enjoyed learning about black hole collisions, hit that like button and subscribe for more cosmic adventures. Share with your space-loving friends too.